Welcome back to the MAT 1140 notes. This is chapter 7.3, page 2. So we definitely want to, number one, fix the typo I just saw on B, but we want to make sure that we can solve problems where it helps to clear the decimal. Now, realistically, we may just use a calculator for everything. What do we want to make this? 0.08. Sure, that works. 0.8. Make it easy on ourselves. Okay, so let's take a look at A. And I'm going to look at the most places behind the decimal. So here I've got 2 places. Here I've got 2 places. And here there's only 1. We want to multiply by enough zeros to clear the largest number of places. So tenths, hundredths, I got to multiply by 100. And again, if I multiply the left side by 100, I have to multiply the right side by 100. This is an equation. Both sides are equivalent. I want to keep them equivalent. So when I multiply 100 times 0.33 gives us 33x. And you can double check with your calculator, but the reason by multiplying by 100 was to get rid of both of those decimal places. When I multiply 3.5 times 100, I get 350. My x terms are on the same side. I'm going to add those together. I get 58x equals 350. Divide both sides by 58. And I could reduce this. I know that 2 is going to go into both of these. But nothing's going to go into both 175 and 29. Okay. On B, again, 2 decimal places here on the left. I have 1 here and none here. But to eliminate the decimal, I'm going to go ahead and multiply everything by 100 again. I get 4x on the left. I get 80x minus 100x on the right. 4x equals negative 20x. I'm going to add 20x, and this example is here to make a point. On the left-hand side, I have 24x. My equal does not disappear, and negative 20x plus 20x is 0. So I can divide both sides by 24. I get x equals 0. That is the only number that is going to make that equation true. And sometimes it feels like a little bit of a letdown when we get 0, but 0 is a valid answer. Okay. So let's take a look at some applied problems here. We have a kiln that fires 8 large vases in 2 hours. So I have 8 vases in 2 hours. We want to know how many vases can be fired in 20 hours. So I can set up a proportion here, which I'm going to find a little more comfortable. So this is what my equation is going to look like. Notice I have vases and vases, both in the numerators. I have hours and hours, both in the denominator. Since we are solving equations, I want to get the x by itself. I'm multiplying both sides by 20 hours. And I am including the labels here just to make sure we're okay with the fact that Hours is canceling on both sides. I have 20 over 2. I can reduce that to 10. 10 times 8 is 80 vases, which makes sense. 80 vases in 20 hours. B is a little different. Now we're talking about 2 different machines that pack salmon at different rates. Okay. So machine A takes 8 hours to pack the day's catch. Machine B takes 5 hours. So let's see how we can make sense of what that means. That means that for machine A, packs 1/8 of the day's catch per hour. Machine B packs 1/5 of the day's catch per hour. Okay, so I've got to reduce both machines to a time that's consistent. So if A packs 1/8 of the day's catch, we're going to use X for the day's catch. B packs 1/5 of the day's catch. Sorry, 1/8 times hours plus 1/5 times hours. We want the whole day's catch. So machine A is my 1/8 X, 1/8 times the number of hours. Machine B is my 1/5 X, 1/5 of the total catch times however many hours, and equals 1, our total catch. We are multiplying everything by 40 to clear those denominators. 40 over 8, and I'm running out of room, so I'm going to talk through that step. 40 over 8 is 5, I get 5x. 40 over 5 is 8, I get 8x. Equals 40. I'm not going to talk about organization here. I get 13x equals 40. X equals 40 over 13. And because we want to know specifically how much time it's going to take, we're going to go ahead and divide this. And we get approximately 3.08 hours for both machines working together. Another typo, sorry. So C, another work issue, work problem. A tank has 2 pipes entering. Pipe 1 alone fills the tank in 30 minutes. So pipe 1 takes 30 minutes. So if you think about it, 1/30 of the tank is filled per minute. So 1/30 tank per minute. When we add another pipe, it now takes 10 minutes to fill the tank. So we don't know how much time pipe 2 takes, but we know if we add them together, it takes 10 minutes. So we want to think in terms of work. And when we do that, we need to set up this equation